My name is Prabir Namhata, Assistant Professor of Malabhu Institute of Technology, Bishnupur. Here I discuss about the introduction of submerged arc welding process. Contents of the presentation is introduction, then principle of operation, submerged arc welding procedures, variables, experimental procedures, advantages, limitation, disadvantage, application, references. Here, what is submerged arc welding? Submerged arc welding is an arc welding process. In those process, the arc is concealed by a blanket of granular and fusible flux, and heat generation of submerged arc welding is generated by an arc between a bare and solid metal consumable wire or strip electrode and the workpiece. The arc is maintained in a cavity of molten flux or slag which refines the weld metal, also protect it from atmospheric contamination. And this is the arc welding. Four type of arc welding are there: arc welding with coated electrodes, tungsten inert gas welding, consumable metal inert gas welding, and submerged arc welding. Here I discuss about only submerged arc welding. Principle of operation. Submerged arc welding is an automatic process. A continuous electrode is being mechanically fed into the joint by power drive rolls. A layer of granular flux deep enough to prevent the flux through is being deposited in front of the arc. Electrical current which produces the arc is supplied to the electrode through contact tube, and DC current can be used in the state polarity, that is electrode negative, and the unfused flux of slag are removed from weld metal after solidification and may be used after screening. Here we discuss about principle of operation, and figure 1 is the submerged arc welding process setup. Here submerged arc welding, the arc maintained under the mass of fusible granular flux. The process is symmetrically figured, and first the flux containing calcium oxide, calcium fluoride, silica is sintered to a form of porous powder. The granulated flux is spread over the joint to be made. The consumable electrode is fed into the flux. A portion of the flux melts to protect the liquid weld pool, whereas the rest of the flux seals in the arc. Both AC and DC sources are used within the welding current in the range of 200 to 2000 ampere. The process is used to have a thick welding in a single run. Obviously, it is unsuitable for overhead welding. And submerged arc welding procedural variable: welding current, welding voltage, and heat input rate. Welding current controls the melting rate of the electrode, weld deposition rate, as well as depth of penetration. Too high a current causes excessive weld reinforcement. Low current gives an unstable arc and overlapping. And second one, welding voltage. The arc voltage varies in the direct proportion to the arc length. With the increase in arc length and arc voltage increases, the more heat is available to melt the metal and the flux. The arc voltage varies with the welding current and wire diameter. And third one is heat input rate. The heat input rate is directly proportional to the current and voltage and inversely proportional to the travel speed. Here HIR, heat input rate, is equal to arc voltage into welding current by welding speed in the mm per second. Experimental procedures: clean the specimen properly, fix the voltage 30 volt, and fix the trolley speed 1.2 meter per minute, and perform welding operation by varying the current and calculate the hardness using Bernal hardness test. Advantages of submerged arc welding process: the arc is under a blanket of flux which virtually eliminates arc flash, spatter, and foam, and extremely high deposition rate and welding speed are possible. Minimum welder training is required, and high current densities increases weld penetration. And disadvantages: initial cost of submerged arc welding equipment is high, limited to ferrous and some nickel based alloy, limited to long straight seams and rotating pipes or vessels, and required relatively troublesome flux handling system. And application of the submerged arc welding: joining of the pressure vessels such as boilers, railroad construction, locomotives, shipbuildings, repairing machine parts, and etc. Here the references, and last of all, thank you.